So a bit of a recap, if you like, on our logs and exponentials. So first of all, logs. Remember, technically this is what a logarithm is. It's logarithm any number to a given base is the index of the power to which the base must be raised in order to equal the given number. Wow, that's a mouthful. What does it mean? It means that if the number is a to the power of x, we can rewrite that to say, well, x is the log of n, but it is also base a. So the bases obviously are consistent. So make it nice, simple one there. If x is log 1,000 base 10, we're basically saying, oh, well, 10 to the power of what is 1,000. So here, 5 to the power of what is 1 on 25? That'll be -2. X squared is 64, basically that one's saying. Now in this case, we don't say plus or minus 8, because obviously -8 squared would also be 64. But when we talk about logarithms, bases are always positive. You don't have negative bases. And this one, x would be 6 squared, so we have 36. So our rules for manipulating, basically they are the index laws. So if you have log a to the power of x base a, the answer would be x. Because basically we're sort of saying a to the power of x is a to the power of x. So the a's, if you like, are sort of cancelling. Now, exponentials and logs, so the other way around, if you now have a to the power of log, again they will cancel because they're inverse functions. Log of 1 is equal to 0. And that sort of comes from the index law, where we say anything to the power of 0 is 1. Log a base a will always be 1, and that's because a to the power of 1 is a. If we want to add two logs together, then the bases, of course, need to be the same. And that comes from our index law. When we multiply, we add the powers. So bases, again, need to be the same, but that one comes from when we divide, we subtract the powers. And this one here is very useful. We can bring that power out to the front of the log. That certainly helps when we're solving equations and what have you. And that comes from, well, a to the power of x, when it's in parentheses to the power of p, that's when we multiply the powers. All right, so let's play around with it. So these are base 10. I want log 20 plus log 5, but I can add those together to get log 100. 10 squared is 100. Log 18 minus log 9 gives me log 2 base 2, therefore it's 1. Now these are all base 4, so we'll have 9 times 8 divided by 6 squared, because we bring the power in. No, what's 9 eighths are 72, of course they are. And 6 squared is 36, so we have log 2 base 4, but 4 to the power of a half is 2, so we get half. Okay, the only logs we know for this question are log 2 and log 3. So using those numbers, come up with log 27. So we have to manipulate 27, but only using the numbers 2 and 3. Well, 27 is, of course, 3 cubed. So I can rewrite that as 3 log 3, and we get 1.4313. Square root of 2, well, that one I can write as 2 to the power of a half. So we get a half of the one they gave us. 12, I can only use 2 and 3. 4 threes are 12. I was thinking 6 times 2 then, but I thought, oh yeah, that would work too, wouldn't it? Because 6 I could write as 3 times 2. So I still get the 3 times 2 squared, and we can manipulate that now and get an answer. So, a bit of a recap, as I say, on the basics of logs.